So a warm welcome to a new week and a new edition of AI Lights. Today we scratch a very important and serious topic, biases, and we will learn about the Bias Project, which is a 4-year research initiative launched in 2022 and funded by the European Horizon program. And it tackles the problem that AI models can reflect and even reinforce societal biases. And the project investigates how this occurs in HR applications and in language models, and how such biases can be detected and reduced. And the Bias Project is driven by 9 European organizations, and one of the national labs is at the Bern University of Applied Science, and the lead of the Generative AI Lab is our today's guest. And I'm glad that you could make it. Mascha, good morning. Hello.
Hi, good morning. I'm happy to be here.
Nice to have you here. Mascha Kurpicz-Briki is an AI expert and professor in computer science. She has been working as a professor of data engineering at the Institute for Data Applications and Security at BFH for 7 years now, if I'm right. And Mascha works as well as the co-lead of the Applied Machine Intelligence Research Group and the Generative AI Lab at the BFH in Biel. And her research focuses on the topic of fairness and the digitalization of social and community challenges. In 2025, Mascha also founded Marcobri Technologies, where she creates formats like workshops and books, as far as I know, children's books, to make AI more understandable and engaging. So great that you are here. And before we jump into the session, I would like to share some information about the setup. Today, we will stream live on YouTube, and the session can be accessed later in our library. And we invite you, as always, to drop your questions in the chat, and we will try to answer them in the Q&A, or Mascha will try to answer them in the Q&A session part. And now, I hope you have a good coffee, a cup of coffee or cup of tea in front of you, and let's jump inside the Bias Project. Mascha, over to you. Thank you.
Thank you very much for the nice introduction. So I will just share my screen with you. So you should be seeing now the presentation slides. And yes, I'm happy to be here to talk about the Bias Project. It's a 4-year research project that is funded by the European Commission and also from the Swiss side. That started in 2022 and so is coming to the end later this year. I will give some details about the project later. So what we'll have a look today first is that we will first have a look at a bit what happens behind the scenes machine learning AI models, so we can better understand why there is this problem of bias that might come up. And then in the second half of the talk, we will look at the exact problem of bias and what has been done so far in the Bias Project, or some parts of it. A lot of things have been done in that project, some parts of it a bit more in detail. So how we are addressing and trying to mitigate this problem of bias. So here, I don't have much more to say. Thanks, Sabine, for the very nice introduction. I think that covered already most of the topics and things or different hats I have currently. And here is also on the top right corner, the children books that were mentioned before that are bringing in the topic in a screen-free and playful way for 3 to 7-year-old children. So let's start with an inspiration. This is a picture that was generated with ChatGPT a couple of months ago. And I used the prompt to generate an image that shows how AI is reinforcing societal stereotypes. This is what I got. I can't say it's a very good picture, I would say, but I think it's a good inspiration to show us that there is a problem. So the problem here, societal stereotypes, and maybe this is already also part of the problem. Societal stereotypes are much seen as a man-woman problem. But of course, all different types of stereotypes and biases that we find in societies are reflected in the AI because it's based on the data. So this can be completely different dimensions, just such as the health status, the origin, the age, and many, many more. Or even intersectional biases between several of them. And this is something that the bias project addresses. We are looking at different forms of bias. We are looking at how a bias regarding, or the groups concerned by a bias might be different in Switzerland, in Norway, or in the US, because this is very context dependent, as we will see later. But to start with all of this and make the line to the technical problem, so bridging this societal problem to the actual technical problem, I want to give a very short introduction to machine learning and language models, as this talk is open to the broad public, so to be sure we have everybody on the same page when diving into the technical details. So when we talk about AI, artificial intelligence today, what we mostly mean is the algorithms with machine learning. This was not necessarily always the case. So AI, artificial intelligence, is something that has been developed since the 1950s. And not always machine learning was necessarily involved in these systems. But as of today, we benefit from these machine learning algorithms to train the models we are using in AI. So why is this different from what I call here traditional software, so non-AI software? We have been using for so many years all different sorts of software. The difference is between these technologies that in traditional software, it works a bit like a cooking recipe. We have a specific amount of different ingredients that are processed step by step, and we have a result. So if somebody else is taking the same recipe of a cake and hopefully does everything correctly, the same output will be generated. Whereas when it comes to machine learning, it's kind of switched. It's less deterministic. We do have data, and we do learn from the data and are with that able to solve problems that we might not be able to solve with traditional software, however, also have limitations that we have to consider when using this kind of application. So what we typically have in machine learning is that we have training data. It can be images, can be text, whatever the use case is. And from this training data, we are building this model in the training process. And this model is then able to either propose a decision, generate a word, and so on. So to do something based on this training data. Let's look at a very simple example. Let's say we want to train a machine learning algorithm to be able to differentiate between cats and dogs. So to do this, here it means it would be based on images. It would be something we call a binary classification problem, because we want to classify data into one of two given categories. And to do this in the training data, we would need a lot of examples of cats and a lot of examples of dogs. Of course, here we have 4, but we will be talking about 100,000 or millions of pictures we would be needing here. And in this particular type of machine learning, supervised machine learning, we would also need with each picture the information whether on this picture we see a cat or a dog. And based on this training data, we have a model that is then able to make a prediction for a new picture that was not in the training data, whether we see a cat or a dog. So here we see already one of the limitations, or one thing to keep in mind with this technology, is that this is an estimation. So even the best model might be right in 98% of the cases, but there are always these 2% of cases where it might be wrong because it's an estimation. Now, the question we have with regard to biases is, these 2%, who are they or what are they? So here, of course, what we will find in the training data, here cats and dogs, will make a huge influence how well this algorithm will work for a specific type of cat or specific size of dog in the final decision. Because the other challenge we have is that this 2%, it's very hard to say why those 2% might be wrong, simply by the way the algorithms work. So what we saw here is an example based on images, but we could do the same, for example, with documents, or we could do the same with text snippets. So this kind of algorithms to train such a model can be used on very different data modalities. So what we saw here was the classification that we see on the upper left corner, where we predicted categories. But this is only one subset of machine learning tasks. So there are a lot of different tasks that we can achieve by using machine learning. Similarly, the text processing and generation, where chatbots is again a sub-part of all of the things we can do with text, using language model, but also using other methods, from extracting information from text up to generating answers in a chatbot or generating summaries, is only also one part of machine learning and of this whole possibilities we have with AI. So often now, since the rise of ChatGPT, AI is seen as much related to chatbot, but chatbots are actually only just a part of what we can do with it. Other application use cases are, for example, making predictions from sequential data or detecting uncommon patterns in large amounts of data, for example, suspicious transactions. When we have a situation, for example, like with the cat and dog pictures, but we don't have these specific labels, so this information, this is a cat, this is a dog, then we can use this kind of clustering to identify groups without having a specific name for the groups. So basically with the cat and dogs, we would be hoping that we would be having a cat and a dog group. Similarly, so now that we have seen a bit how we can train this classification, similarly, language models are, said simplified, trained in a way to predict the next token or the next word, said in a simpler way. So this means that we have a lot of textual data that is used to train a model, and the model is able to take a partial sentence and complete it with the most probable next word. So this means if we have an example like Anna went to the forest and saw A, the word tree might have a high probability, so be most likely a very good match for this sentence, content and grammar-wise. On the other side, lion might be possible, but at least around here, less likely. And smiled doesn't fit already from the textual structure of the sentence. So it would have a very low probability. So these models that is predicting the next word would then be, for example, the base in different applications. And one application here is chatbot. So if we have any problems of biases inside these models that comes from the training data where it was trained on, because, for example, the way men and women are depicted is different, or the percentages in which men and women work in specific domains is different, this is encoded mathematically inside this base model and then has impacts on whatever tasks we are building on top of these models. To better understand that, I want to take a bit deeper dive into a more technical aspect here quickly. So in the bias project, also in the results I represent, we often talk about these word embeddings. So I'm using here the word embeddings that were used before the transformer architecture. Transformer architecture is the current architecture we are using as a foundation for all of today's, for most of today's AI models. And word embeddings is just a step before, but it's a very good way to show the problem from a technical perspective where it comes from. So the idea of word embeddings is that for us humans, it's very good to use words in a natural language, let's say English or German as examples for a natural language. So if I say the word cat, we have a lot of associations based on what we have seen and learned about how a cat could look like, what sound it makes, and so on. So a lot of things are associated with that word. For automated processing, this is harder to capture. So here we would prefer to have a mathematical vector of, let's say here in these examples, of 300 dimensions, so a large list of numbers that captures these dimensions that we intuitively know when seeing the word cat. And these are these word embeddings. So we have some sort of dictionary for, in this case of these word embeddings, for each word, like cat, to a mathematical vector. So instead of translating cat to the French or the German word, we are translating cat to this vector. So why is that useful? It's useful because words that have a similar meaning have vectors that are closer together. So this line of numbers that we have seen before is positioned somewhere in a high dimensional or a relatively high dimensional space. And the vector of the word dog and the vector of the word cat have a distance that we can measure. And if they are closer together, it means because both are pets, they have a more similar meaning. And the vector of the word thunder or storm will be further apart. So with this kind of technology that has been developed over the last, let's say, 10 years, we are able to automatically compute meaning by doing mathematical operations. And this has a huge advantage for many applications and is the foundation of what has enabled these fast progress in natural language processing over the last years. Because with these properties, we can make some calculations like saying man is to king as woman is to X. And by taking from this dictionary the mathematical vector of man, of king, and of woman, we can compute X, which will be very close to the vector queen. So this is very useful for many applications, but at the same time brings us to biases in word embeddings and language models. Because in the same way as relations that we want to encode are encoded in this vector space, unwanted relations, so relations that are in the training data, but we might not want to reproduce or reinforce, are there as well. So for example, this is a very quite famous paper nowadays. It's already 10 years old, but was one of the initial papers showing this problem, is that in some of the word embeddings, it was shown that father is to doctor as mother is to nurse. Because of the data, the way it was depicted, the way it was represented, this is the relation that was then encoded in these mathematical models. So this is also where it starts to become a bit normative, because there are some relations that we definitely want to include, because that's also the reason why all of this works. So for example, we might want to say that the banana is rather yellow than red. So it's a relation that needs to be there in order for these systems to function. However, there are some relations that we don't want. And already making this decision is part of the problem of bias detection and mitigation, on saying these are the wanted and these are the unwanted relations, because from the technical perspective, it's the same problem. It's a relation learned from the training data. So this, was one of the early examples of all of these different problems of bias in AI applications that we had, ranging from a wide range of application use cases and of data types. So, for example, there are a lot of problems reported, for example, with the passport checker that showed a bias against dark-skinned women. There is the famous recruitment example where the system was trained on historical data. However, in the tech domain, where there were few examples of successfully hired women, just simply because there were less women working in that domain, which then led for the system to develop a bias, because it was just based on this historical data without pushing it or without considering this problem of unbalanced data. There was also a chatbot that was trained on interactions with Twitter users, which also led to quite quickly to very problematic statements. So these are just 3 examples, but over the years, many different examples have been shown. And also, I have to say, a lot of awareness for the topic has been created over, let's say, the last 5 years. But it's a very difficult problem to solve technically, because it's mainly rooted in societal biases and in the data we have available for such systems. Another quite well-known example of bias is the example of machine translation. So here, typically, we encounter this tricky situation for the machine learning when we are translating from English, for example, to a more gendered language, like German or French, where the expert could have a male or a female translation. So what happens often in many translation engines is that some professions are converted or are used the male version and others the female version. So here we see quite stereotypical how the expert and the doctor are male and the secretary and the nurse are female. So this is in a moment where we have 2 or more options on how to translate, and the most likely in the view of the model option is chosen. So this is another example how we find these kind of problems, from image generation to text generation to machine translation, and many, many different other types of machine learning, just simply because it's relying on the data that is available. So that's what brings us more concretely to what we have done in the BIAS project. So in the BIAS project, we are looking at two specific aspects. On one side, we are looking at AI applications used in the labor market. So we have some focus on some HR applications, especially our colleagues from the Norwegian University of Science and Technology that worked on fair recruiting approaches. But we are also looking at the human side. So we are looking at how human biases are actually reflected in the AI applications, and in our case, especially in language models. So this is, again, tricky itself because, as mentioned, there are different biases in different cultures, in different regions that might be reflected differently in language resources of the different languages. And of course, from the technical perspective, we are looking at how can we, first of all, measure this and reduce these biases by applying different methods, both technical, but also in the sense of sensibilization and awareness raising. So I will bring this later, but I just want to point it out also here that even though the BIAS project is ending later this year, we have put all of different findings in an e-learning course that is available online and has been launched a couple of weeks ago. And that is for free. And people can register to have a more deep dive in partially what I have been saying today, but also all of the different aspects from the bias, from the social science perspective, and to really see how what are the things that need to be known to make responsible decisions in AI development, especially in sensitive domain such as the labor market. So in the BIAS project, we have been working on different technical components. So on one side, as mentioned before, our colleagues in Norway have been working on fair recruiting with case-based reasoning, which are fully explainable approaches, not relying on machine learning, but using different manually curated data sets to solve this problem. And from our side, we have been working on one side on the mitigation of bias in text-based recruitment applications. So here we know from research that, for example, the way men and women write might differ. So when dealing with the cover letters, for example, there might be differences when processed automatically, the way these letters might be processed, even though all of the sensitive attributes have been removed. And finally, and this is what we are going to look at now a little bit in detail in this very last part of the talk, is the bias detection and mitigation in word embeddings and language models. So I'll discuss some of the challenges and intuition on these methods to fix or trying to fix or reduce this problem we have seen before, that the banana is yellow and not red, which is wanted, but what we don't want, for example, to have male first names being associated with programmer and CEO, and female first names being associated with secretary or nurse only. So to do this and to cover also this or investigate this aspect of having different biases in different countries, we have been rooting our technical development in co-creation activities. So we have conducted 15 workshops, so 14 of them in the different partner countries, 2 for each partner country. And we have also invited to this a wide range of stakeholders. So to have all of the different perspectives, including workers, civil society, technical AI specialists, but also HR specialists. So in total, we reached more than 300 people that helped us to craft a bottom-up these novel bias detection methods. So the key question, we're doing different activities, but one of the key questions relevant for our work here is how are potential biases expressed in this cultural context and in the local language? So what are typical stereotypes people might have? Or what are things that would be coming up in a discussion when looking at an applicant and looking at a job ad? Would they be saying, oh, but this person for this and that reason might not be strong enough for this job? And what are the things that are somewhere there culturally, but are very hard to capture? So based on this, based on these insights we got, based on the literature, based on the interdisciplinary collaboration with, of course, the researchers from the social sciences and humanities, we came then up with these novel bias metrics that are language specific and allow us to measure, for example, the Icelandic stereotypes in the Icelandic language resources to really understand what are the differences and what is reflected. So to give an intuition when we say reducing, what that means, again, a bit in a very simplified way, but the intuition behind this is that we want to move, so here, of course, in much less than 300 dimensions for the visibility, we want to have some characteristics that are not attributed to specific, here in this example, male or female, but could also be the origin or could be another property. So for example, we would not want Bob to be close to CEO and programmer and Alice, because it's a female first name, to be close to nurse and secretary, but we want these to be in the same distance of these two. So this is one example. So this, and that's a bit also the limitation of general state of the art, is of course focusing on very specific biases that have been detected. But we have to be aware, and that's what makes the problem so complex. So even though even providers from tech companies have added alignment, there's a lot of work that has been done in this bias mitigation, but it's very tricky because the number of potential biases we have is very, very large and very hard to capture. So that's what brings me to the challenges. So for us in our research part, it was in particular also of interest to transfer the knowledge that has been generated for English. So a lot of work had been done before for the English language, but to transfer this to the European languages, where we have some specific challenges apart the stereotypes or the biases being different. So on one side, of course, our work indicated, as mentioned before, that there are cultural differences in how bias is actually reproduced or reflected inside these language models, simply because there are different stereotypes, there are different immigration groups in the different countries, which impact the perception of bias. And this is reflected in the data, which is again then reflected in the models. We also have the challenge that we have a specific linguistic properties, so that some methods developed for English, they wouldn't work for languages that have, for example, a grammatical gender. So whereas in English we have the, in German or Italian or French we have also the grammatical gender, which is not something we would need to mitigate. We also, so one example here is that the expert can be two different words in German, depending on the gender of the person, which adds additional complexity. So this might be a bias we want to address. But on the other side, we have, for example, the moon being of female grammatical gender in Italian and of male grammatical gender in German, which wouldn't matter and which is not needed for the bias detection and mitigation. So this is much more challenging in such situations for the technical methods. And of course, and this luckily we had this foundation in the bias project, is that to study this topic, which is really an intersection between technology and society, we need an interdisciplinary team. So this revealed crucial in our project. So what's the takeaway message? We have done a lot of things. The field is advancing, but still we need the human in the loop because the problem is challenging and it's not a problem that can merely be solved technically. So here I'm presenting this approach of augmented intelligence instead of artificial intelligence, which comes a bit from the fact that I'm not a big fan of the term artificial intelligence as we are using it right now, because it implies somehow some autonomous intelligent entity, which I don't think is what we should be aiming for. We should be aiming for smart tools for automation, for efficiency, yes, but under the control of the humans. So to support humans rather than replacing them. And AI is a tool, and somebody is responsible of using it and of making a responsible use of it. So the key takeaways are to be aware of the limitations on one side more in general. Is the use case actually suitable? Is the process where it's embedded in with the control mechanism by the human suitable? On the other side, of course, checking generated contents for correctness. Even if it was right 20 times, it might be wrong the time after. And be critical. So here, bias, stereotypes, as seen in today's talk. Yeah, so with that, I conclude here, and I'm very happy to go into the discussion and answer any questions you might have. Also adding here again the link to the bias e-learning course or also the children books. And if you want to connect on LinkedIn, I'm happy to do so. Thank you.
Wonderful. Thank you, Mascha. We have a first question, and we are opening up also the mic. So Dimitro, if you would like to jump in, you can ask for yourself, or I can also read it as you like.
Yeah, thank you so much for this talk. Really appreciate it. I myself was working for a similar project, but also kind of correcting the bias for numerical data. For example, like gender bias in salary data. But I'm curious how to do it, or have you investigated potentially similar methods how to correct the biases in textual data for LLMs? Because of course we know there are many of the biases we have found, including those you have shown.
Yes, so I mean there are many different approaches one can take. So there is also a lot of literature working on different aspects. So maybe I can just mention a few here more in detail for those who are interested. So I mean typically we would have the whole pipeline. The pipeline meaning we have data, we have the training, we have a model that is then running in inference, and we have the user interacting with the model. So let's say if we have a prompt-based model. So at all of these components, we have different possibilities to try to mitigate the bias. So of course, ideally, we would already have, like in a perfect world, we wouldn't have the bias in the data in the first place. So fixing this is very challenging, but it's one approach to say, especially when you have very well-structured data and you know where your problems are. So whenever we are dealing with the data, the first thing is that we need to know what are our biases. So once we know, we can try different things on the data to put, for example, a counter record or to modify the data. Of course, always, which might bring some other drawbacks as well. So one point of attack here to fix the problem or to mitigate the problem is the data itself. Then there are ways that people do, so if we talk about word embeddings, to do on the embeddings, trying to measure and fix things on the word embeddings or on the existing models, or consider it during the training process. To have, for example, within the training process, some components already pushing in one direction or the other. And finally, we have the whole topic of AI safety and alignment, where we are often also working with components that are in the appropriateness of the answer. So even if the model is biased, we are trying to mitigate it at the interface between the model, the application, and the user by trying to prevent the system to output something that would be seen as inappropriate. So for example, by having a classifications or filters in this interface here. So this for the language models, but similarly for when you have numerical data, you could be working on the data or correcting later, as long as the biases are known. So the big problem are also all of the blind spots, all of the biases we might not be aware of.
Thank you. Some other questions in the chat? There are none, but maybe someone wants to jump in. So I have also one in my head. So I read about this debiaser, which was developed during the project, right? Can you maybe share a bit about that? What is it? And is it a tool anybody can use, or is it finalized, or yeah?
Yeah, so the debiaser is the term we used before, a bit of everything. So, I mean, it's a bit challenging, and debiasing here is meant, of course, in the sense of reducing biases. So it compromises more of the technical components we have developed here. And actually, it's not one tool. So in the end, we have come up with different GitHub repositories that are already available and that can be used. I think they should be linked on biasproject.eu. I think I have the link here. So there you'll find a tab, which is the NLP demo. And there we have a website with all of the different publications and GitHub repositories that are already available. And there are some tools from the proof of concept research we have been doing in this project that we are again sharing for the community for, of course, future researchers.
Okay, thanks. So, any other questions? Yes, Roman, would you like to jump in?
Yeah, hello. Good morning. Thank you very much for this interesting thoughts and your research. My question is maybe a very simple one, but I mean, you can train AI for almost anything. Can AI also be used or trained for detecting bias in materials we use, documents, whatever, or even in its own logic? Is there some kind of a or are there like thoughts or projects or a vision that AI could maybe become so self-conscious that it corrects itself with those biases?
Yes, so yeah, about the self consciousness, that it goes a bit far, but I mean, what we do is to use AI as a classification task. So also one very famous example is maybe the research work being done on toxic or hate speech. So there's quite some literature on how people use classification models to filter or detect these kind of harmful contents. So this works with the same principle as the cat and dog picture. So we have harmful, not harmful. And these kind of models can also be integrated in the pipeline, for example, to filter answers. So whenever there is an answer that before it goes out to the user, it's like, okay, review this one, it's too toxic. So these kind of flows. And similarly, we can also detect biases with sufficient training data, absolutely. So this is something that is done. But that's why I'm saying reducing, because it will then cover maybe some of the biases. Then there will be biases of not having seen specific biases in that training data. There is the percentage of where it doesn't work correctly and so on. But that's a quite efficient way also of mitigating biases.
Thank you. So I think we can come to an end for this morning. I'm just sharing our next AI Light sessions here. So we will have some interesting topics coming up. Mascha, thanks again for joining second time with a very exciting topic and a very serious topic too, of course. Wishing everybody a great new week and see you soon. Yeah, bye-bye. Thank you.
Thank you very much.
Ciao.
Bye.
Ciao.